Hello everyone, I'm Hitimana, lecturer and researcher at the University of Rwanda, College of Science and Technology, School of ICT, in the Department of Computer and Software Engineering. Based on different challenges faced in the agriculture sector, especially in Rwanda, University of Rwanda has aims of contributing to the problem solving by doing research which is applied to the community. From that aim, the staff from computer and software engineering and other from biology, they sat down and brainstorm and see how they can contribute to the community by making a joint venture project to support the farmers by using technology applied to the agriculture sector. It's from that regard we proposed a project which is to detect the coffee leaf diseases from plant, but especially we started from cash crops, which is coffee plantations. So that project is being implemented 2 years, but now there are some activities which have been done, which are going to be shared so that we can know or we can see how technology is supporting farmers in our context, which is Rwanda. So that will come as what we used to say, to solve our own problem. So in order to provide or to do our research, we made a methodology to gather some information or some data which shall support us and also which shall allow us to check if the tool we developed are valid. So we sampled different cooperatives which shall also allow us to test the tool we will come up with. Among many coffee cooperatives in Rwanda, we sampled 10 coffee cooperatives by considering geographical coverage. From east, we sampled 2 cooperatives at Ngoma district, where we are working with RWACOF Rukira. It is a coffee washing station. And we sampled another coffee cooperative called ABAKANGUKIYE KAWA, Ngoma. They are farmers. We collect a lot of information about coffee diseases. And then we moved to northern province. We sampled 2 districts because it is having high altitude. So where at Gicumbi, we sampled 2 coffee cooperatives, which is Nova Coffee and MAYOGI Coffee. Then we moved to Rulindo district. We selected 2 coffee cooperatives as well. We met farmers of TUMBA Coffee Limited and also farmers for COCATU Cooperative. And then we moved to Western Province, where we met farmers at HOBE Limited. This is a coffee washing station. And we moved to another coffee washing station. We met farmers supplying coffee at RWACOF coffee washing station, which is located at Rwinyoni. It is known as RWACOF Rwinyoni. And then we moved to south. At the south, we focused at the Huye district, where we sampled 2 coffee cooperatives. From them, we met farmers at the famous coffee production, which is called MARABA, but it is mostly called Abahuzamugambi. And we met farmers. They shared some experiences and challenges And then we went to another neighboring coffee washing station. Among those farmers, we communicated or we met at least 30 farmers per each coffee cooperative, because we designed a questionnaire just to gather some information. So after coming up with the findings, we sat down and we checked the characteristics of coffee leaf diseases, and then because we even took some photos, and then we sat down and did research and designed a tool which can support all those farmers, because they shared with us different challenges and how they met, and even the managers told us that it is very hard to report the information to the in-charge people at the district and even at RAB research department. So from the problem statement, or from different challenges we faced, the farmers are facing, we proposed to design a reporting tool, which is a mobile app, smartphone mobile application, with an AI embedded to detect a coffee leaf disease and report that detected leaf disease in real time. So the expected outcome is to come up with a mobile application to be dispatched to different selected best farmers, but not best, but some selected farmers, so that they can report different diseases, and all those information shall support the decision makers, because we shall also design or implement a web application which can show the decision makers all those reported diseases, so that they can apply different measures to fight against that. So we saw that there are a lot of measures used to fight against those diseases, but the problem is the decision makers doesn't have enough information or enough data to decide how to go with the solution. So we are wishing that this technological tool shall support or shall allow the people at the end, which are the farmers, to report the diseases found in real time, and then the decision makers, by one click, they can see how things are being reported, and from those data submitted, they can take a decision and check how they can conduct what we call trainings to farmers, how to treat coffee plantation, and also how to use fertilizers, and also how to use pesticide, but which cannot affect human life. So now we can say that the tool is under development, but because we mostly do the implementation into phases, the first phase was to meet with the farmers just to correct the challenges and to correct the data which shall be used. And then as researchers, we have to sit down and train. As we said, this is relying on artificial intelligence, especially machine learning and deep learning, and then take all those pictures collected from farmers, label them, and then train them, because we will come up with a solution or with a model which can detect and classify either a leaf is infected or it is not infected. By knowing that the leaf is infected, it have also to specify the name of the disease. So we may say that in technical terms, we have disease detection and recognition. And then the third operation is to report the disease. By reporting, we shall make sure that the smartphone shall report those information about the detected disease and the geolocation, where exactly that disease is detected, because that shall allow decision makers to say that, for example, at the East Province, we have around, let's say, 50% of accuracy of, let's say, coffee rust disease. And at the North, they are, let's say, 10% about rust disease. So that shall also react to the concern we used by sampling different cooperatives by saying that maybe at the East, because most of readings says that when the region with hot season or with the hot climate, the coffee rust can be existing more than the cold region. So we want to prove that by getting this application or this tool working. So the last but not least, we also thank the coffee washing station managers and CEOs who supported us to allow us to meet the farmers. After, of course, a lot of worries, they understood that that solution, if it is successful, it can also secure the production. The reason why we are working with the farmers is because they will test, they will contribute in testing how the app is working, and if there are some challenges, so we shall sit and debug or correct them so that the farmer can be happy in using that technological tool. So the assumption we are having, it's not even the assumption, because the farmers, it doesn't regard to the background, the educational background. We are planning in our development to make it into multiple languages, so that the farmer who doesn't even understand foreign languages, let's say English or French, he can switch to Kinyarwanda and use the application. In order to develop the machine learning model, the following architecture have been considered. This is an overall architecture of the flow for developing the model which shall be used by the farmers. So the data set we collected from different cooperatives have been compiled and then feeded to different convolutional neural network models with the same, of course, with the same architecture, but with different layering and internal hidden connectivities. So among those, we select the different transfer learning techniques, Inception, V3, this one, and that one. So the concern was to find out the best among those 5 so that it can be deployed to the web platform and the mobile application. So among those features, we find out that because they are all of convolutional neural network architecture, they somehow have the same accuracy. So this is the architecture. We are going to show up the implementation part. Thank you. From the previous architecture, we did implementation just to do some kind of training, and then we come up with those 5 models. So we are going to test how the system shall work, but of course this is a testing point. So we have to try it, and among that, so here are the list of all those 5 models, and we can select one depend on the one you want, but this is being done for testing purpose. But for the mobile, we shall select the best one so that the farmers must be having that. So then the testing phase is done like this. So you have to select the data set. Those are different coffee leaves, and then you browse it, and then you select the model, let's say this one, and then it is being tested, because the model will accept the image and it will load and process it. So there is the output will be shown downward. So it seems like this reef is healthy with a confidence of 99 point something. So it means it is healthy. So that we are using DenseNet. And let's choose the damaged one. Let me choose this and execute. So we will just check the output here. So those ones will be shared or will be displayed to the either once the farmer is using it, because this model shall be deployed. So this is the raster with the confidence of this. So we have many, but we test those with those leaves, and I think the next step is to deploy this model to the dashboard so that managers can use it to check the problem of the coffee reported, and also to the mobile app so that the farmers shall use it for testing or for reporting those problems of coffee leaf diseases. So I think they will not have any problem to test because they are already given the smartphone. Thank you very much. See you next time.